Here I've started off solving the equation using the property that the natural log of a times plus the natural log of b is the natural log of a times b, to rewrite this sum of logs as a log of a product. Now we go to exponential form. To rewrite the above equation, and this is to the log base e, when the natural log is the log to the base e. So writing this in exponential form, we have the argument here, which is 1 times 1 is 1, 1 times negative 4x is negative 4x, negative 6x times 1 is negative 6x, negative 6x times negative 4x is positive 24x squared. And on the other side, we have e to the second power when we're writing it in exponential form. Okay, let's rewrite this. We have 24x squared, and negative 4x, negative 6x is negative 10x, plus 1 minus, let's subtract this e squared from both sides. Now we need to apply a quadratic formula to this, where a is 24, b is negative 10, and c is equal to that 1 minus e squared. So we get x is equal to negative of the negative 10 is positive 10, plus or minus the square root of b squared, that's 100, minus 4 times a is 24, times c is 1 minus e squared. Where e is just a number, a constant, over 2 times 24. So that's what we get for x. Now, 1 minus e squared is negative. This is negative. That makes this whole thing positive. So under the square root, it's all positive. It's a number bigger than 10. So the number here is bigger than 10 because this is actually positive. Nothing is subtracted. It's bigger than 10. Therefore, when we subtract 10 minus something bigger than 10, we get a negative. We can't pick this negative then. That negative results in this log being positive. Uh-oh. Let's evaluate it first. I don't want to get... let's just evaluate this thing first. Sorry about that. What does x equal approximately here? So here we go. E squared, so that's 7.38. 1 minus that. This is negative 6.389 about, times 24, times 4. So then 100 plus that, and we get, under the, well, the square root is approximately under the square root here we have 20, well there's no, I already took the square root. So what we have here is 26.708, 601, 3392, approximately. So let's store that. I'm going to store that number away because we're going to need that one. And let's choose the plus. We've got two possible answers for x. One choosing the plus, and one choosing the minus from the quadratic formula here. Choosing the plus, we add this 26 to 10. That's 36.70 whatever, and that's divided by 48. So this number is about 0.7647625279. Round it off to the nearest millionth, it's 1, 2, 3, 4, 5, 6. The next digit over causes us to have to round that up to a 3. So there's this possible answer, rounded off to the nearest millionth. Okay, then for the negative, we end up with okay, I'm going to recall from the memory of the 26, subtract it from 10. That's negative 16 something divided by 48. And this time we get negative 0.348095861. Round off to the nearest millionth, 1, 2, 3, 4, 5, 6. The next digit over is an 8, so we have to round the 5 up to a 6. These are two possible solutions, but we have to make sure they don't make any of the logarithmic arguments negative in the original equation. For example, 4 times this one, that'll be positive, so this being negative makes the argument positive for both, so this one's okay. This one doesn't cause us any problems, but this other one, 764,763, if we multiply that times 4, or multiply it times 6 even, it's larger, it becomes too big. It causes this to become negative. So this time the positive one results in a negative here, and it also results in a negative argument here. So logs don't eat negative numbers. So that, since it causes the logarithmic arguments to become negative, we have to exclude this one. And that's our only solution then for x.